Recording and.
All right, guys, we're starting 6.1.1. How can I plot points in 3 dimensions? So obviously you guys done stuff in 2 dimensions, right? That's the way we tend to graph. Graphing in 3 dimensions can be a little tricky. So if you go to GeoGebra, I'm not sure if you guys saw that last year in geometry, or if you took geometry this summer, if you guys did that. But you can actually graph stuff in 3D and kind of check it out. So this is kind of a quick image of a 3D graph. Does do it? Okay, but let me go to GeoGebra. Let me pull it up right now. So GeoGebra, we'll do 3D. Here, oh, perfect. 3D graphing, perfect. There we go. Yeah, there we go. So, for example, what if I were to graph y or x equals 1? So you graph x equals 1. What did it just do? It's kind of weird. Like, so let me clear first. You see nothing, right? The x equals 1. You see, it gives you like a plane. If I just do x, it does a line, right? Or if I do like y equals 1, see, it does another plane. If I do z equals 1, there's another plane. So what's happening is you have 3 axes. You have the x, the y, and the z. The z usually runs up and down. The x and y, I think this is x, that's y. I think red's x, green's y. But you could do this, like x plus y plus z. So basically, you're getting these planes. That's what's happening. And any point on the plane would satisfy that equation. Like, for example, 1, 0, 0 would satisfy, or 0, 1, 0, or a third, a third, a third would satisfy, or -1, -1, and 2, which are -1, -1, 3. So that's what a 3-dimensional plot looks like. We're not going to get too deep into that because it is a little confusing. But yeah, I typed in different equations. Again, you get like all these kind of weird things. I mean, if you want, you could actually get even crazier. I mean, I could like actually make this to the 2nd power. And maybe like add some other numbers, like maybe put like a 10 here, plus x. Yeah, see, I'm getting all these weird shapes now, right? So yeah, you can totally just go crazy with this stuff. Let's move on to over here. So a point in 3D is represented as an ordered triple. Means it'll look like this: x, y, and z. So it's going to have an x coordinate, y coordinate, and a z coordinate. A linear equation 3 variables in this form could look like this. All these constants represent coefficients. A line in 3 dimensions can be represented. It's kind of weird what they said the word line, but by a plane. So for example, what if you have like x equals 1? If this were the x-axis, it would kind of look like this. It's kind of hard to draw, but it would just be a plane touching the x-axis at 1. And crosses. So basically, every x coordinate will be 1 on that plane. So that's what's happening there. When we have 3 linear equation, 3 variables, we can get one solution or a point of intersection. Because that's what we're trying to accomplish here. How do we find points of intersection with three equations, three variables? Because if you have like all these different planes, they could just meet at one point. So let you guys copy that. Really, the heart of the matter is number 4. That's what I really want to get at, because that's what we're going to be working on. But at first, we have to kind of talk about what a 3D graph looks like, because a lot of Algebra 2 classes don't do that, and people just don't know what to do with 3D graphs. Want to at least introduce it. It's not a terribly important concept, but just good to talk about, because we're going to now solve equations with 3 equations and 3 variables. Then you have a question? Go ahead. No, it's too hard. It's too hard to graph 3D. It's easy to use technology to do it. By hand, it's too hard. Just want to show you how it looks. This is what I really care about. Number 4. Okay, so we want to solve. So when you solve these, I would use substitution / elimination. So let's take a look. Negative x plus 2y plus 15 equals 6. Negative x plus 2y equals negative 9. 2x minus 3y plus 5 equals 10. 2x minus 3y equals 5. So far we're okay with what I just did? What would I do? I replace z with 5. I'm going to put that 5 there and put that 5 there. So negative x plus 2y plus 15 equals 6. 2x minus 3y plus 5 equals 10. Just do that. We're okay with that so far? We good? Okay. Next up, you have 2 equations and variables. How are you going to do that? What's your process now? And there's no right, like one way. There's several ways you could do it. But now you have to work these 2 out. What thoughts do you guys have? Let me stack them first. Negative x plus 2y equals negative 9. 2x minus 3y equals 5. What do you guys think? What technique do you guys want? You could do a few ways. You want to substitute? You can. You guys want to eliminate? What if I did elimination? How would that look? You guys remember this? Right? So what happens? I get negative 2x plus 4y equals negative 18. 2x minus 3y equals 5. Add them up. Y equals negative 13. Does that make sense? And then how would you get x after that? What would you guys do? Yeah, totally. You plug back in any one, your choice. Let's say I plug back into the second equation. Two x plus 39 equals 5. 2x equals negative 34. X should be negative 17.
So where do you get the 13 from?
Well, we solved for y. Unless I did it wrong. I could totally make mistakes. Let me know if you guys see an error. Let me back up a little bit. It's a lot of steps. I know, I get it. I'll back up. Okay, so yeah, so you saw how I got those 2 equations in terms of x and y, right? Okay, good. And then you saw I stacked them, right? And I multiplied the top equation by 2. And why did I do that? Why did I multiply the top equation by 2? Exactly. So now you have 4y, you have negative 2x plus 4y. And it's good I'm doing this because I can make a mistake too. Maybe I'll catch my errors if I did make one. So you have that, and then bottom stays as is. And now I'm going to add the equations, right? Because that allows me to cancel out the x's. So I get y equals negative 13. Plug back in either equation. I get 2x plus 39 equals 5, or 2x equals negative 34. Therefore, x is negative 17. So the answers are going to be, you're going to write your answer like this. -17, comma, -13, comma, 5. You can plug back in either equation. I'll plug back in either equation. I should work itself out. 17, -9. Yeah, it works itself out. So how do you check the solution? Plug it back in either equation. So let me erase some of the stuff here because I need some space. Plug back into all equations and check see if it makes sense. So that's how you check your work. So, all right, questions? We're good. All right, let's try this again. For 620, consider graph x equals 4 for each of the following problems. So you're gonna graph it. Okay, so I'm gonna do each of these graphs really quickly, and then we'll do 6. 6 is a doozy. Just saying, no. It's a little crazy, but we'll make it work. Don't worry. And then we'll have some homework after that that you guys can do. And actually, so Ben, you said we could do some Desmos?
Yeah.
Let's give it a try.
Like Desmos.
Where I click?
That's what's fun.
Right here?
Scroll down.
Oh. Just click that. Okay.
You can just get down to it by searching up like Desmos 3D graphic calculator.
Hold on. Desmos 3D graphic calculator. Uh-huh. All right. We're going to use this in just a little bit. Okay. Well, first off, let's answer this question here. X equals 4. If you graph on a number line, it's one dimension, right? That's easy. You guys can do that. That's not hard. That's just, here's a number line. Here's 0, 1, 2, 3, 4, and you just do a big dot there. Easy peasy. If you graph on an XY plane, that's also super easy. 1, 2, 3, 4. You got that. Then if you do if you're doing a 3D plane, that's how you should draw a 3D plane. And that would do it's a little tricky. So there's 4. This is a little tricky to do. I'm gonna do my best. Bear with me here, guys. Do we have shapes that we can do? Maybe. Let me switch. I don't like that color. We select it. Come on, select it. Whoa, what did I just do? Oh my goodness, hold on. All right, let's figure this out. I can't rotate it, could I? Okay, I think yeah, I'm kind of total failing here. That's okay. You kind of draw something kind of like this. It's kind of hard to do. Yeah, it's really hard to do, but basically what you're doing is like you're taking like a piece of paper and you're putting it x equals 4, and it's going to be parallel to both z and y. So this is a plane that's parallel to the y-axis and the z-axis. That's what's happening there. and crosses 4 on the x-axis. That's what's happening. But again, I don't think that's what we're really going to really ask on an assessment because it's just graphing these are just kind of tricky to do. If I were to type it here, you want to see for yourself. There you go. See, put that big block there. And where I put that big block at x equals 4. What if I switch it to y equals 4? See, put a big block there. What if I put a z equals 4? See, it did like that. So there's a plane. Actually, it's not a block. It looks like a block, guys. Sorry. The toy looks like a block. See, it trips you out when you look at it, right? It looks like a red block. It's actually just a piece of paper that's touching at 4. What if I put 3 there, or 2, or 1, or 5, right?
Why did it go there?
It's just touching the x-axis at those places. Like I could do -1, -2, -3, -4. Yeah, think of it for recommends. I like to spell in GeoGebra. Things just look better. So desmos.com/3D. That's good. Cool. Now let's do this one. Now, here's what I'm going to do, just so we know we're doing this right. So when you're doing your homework, I strongly recommend you use this link. I'll put the link in Schoology as well. Let's type in these equations here. X plus 3y minus 5z equals 13, right? Then 4x plus 3y. I mean, we're going to work this out by hand. Don't worry. Equals 37. 2x minus 5y plus z equals 4.
How are you supposed to?
Yeah, these don't touch. Do they touch? Yeah, yeah. You're asking how are we supposed to solve it?
Yeah.
I don't know. So yeah, because I'm not too familiar with this tool here. I know how to solve by algebra, but yeah, they should be touching somewhere. But okay. Anyway, not sure that really helped us. Let's just work this out. Okay. Take a deep breath. This is gonna be kind of crazy. Okay, bear with me, guys. What I would do is get z by itself here, or actually you can get x by itself. It's up to you. You can get x by itself in the first equation, or z by itself in the third equation. Kind of up to you. And then I'm going to do this. 4x plus 3y minus 5 parentheses hold on, equals 13. No, equals 37, my bad. And this one, x plus 3y minus 5, -2x plus 5y plus 4 equals 13. And then we separate these so I don't confuse them. Okay, take a step back. Make sure you understand what we did.
A lot of it's like brain surgery, right? You gotta be really careful. You see, you got to see by itself, right? See how substitute z into the other ones. Okay, right? I think I wrote it incorrectly. Just be careful. Okay, we're okay. Wait, I have to use the bar. Oh, I moved these over. The 2x and -5y. So how you going to just drop, right? And please ask questions. I don't want to rush because we can easily make a mistake here. Okay, this is where mistakes happen. It happens when you don't distribute correctly. Right, like first correctly. What am I distributing here? 5 or -5? -5. Yeah, I like those that one. So let's see. Monty, go ahead there.
Can't you just like do elimination?
That works too. You could do that also. You could do that, but then you'd also have to make sure you limit the z with the other equation. I can show you that after I finish. I'm just going to do it this way because it's a little more standard. But yes, you totally can, 100%. 100% you can. Plus 10x minus 25y minus 20 equals 13. Clean it up. This is the part where mistakes happen, guys. 11x minus 22y equals 33. Okay. Now let's do the next one. 4x plus 3y plus 10x minus 25y minus 20 equals 37. 14x minus 22y. Oof, I'm feeling better about this now. I'm feeling better about this because what do I notice about both equations? What do they both have in common? Yeah, the y coefficient is the same. Yeah. Okay, I'm feeling really good about this now. I swear to you, I promise you, if I make you do this, I will give you something that works out very nicely. But here's the thing. I'm not going to ask you to do it this way on our test because there's actually even a better technique, which we'll learn later in this unit. I'm not going to do it today. There's actually a technique that saves you like several minutes. I'll show it to you in the calculator, but I'm not going to get into the theory behind it or all the mechanisms behind it until a later time this unit. But there's a better way. This is not the way to do it. I'm showing you like the painful way. But fortunately, this worked out nicely. That gets 3x. The y's go away, you get 24. X is 8. So I have 8 here. Then I gotta get y. I could do maybe this one here. 14 times 8 minus 22y equals 57. Negative 22y equals, need to calculate this one. 14 times 8, 112, 57 minus that number, negative 55, I think. I think at 2.5. Yep, 2.5. And right below, I'll do z. Z equals negative 2x, which is negative 16, plus 5 times 2.5, which is plus 12.5, plus 4, which should be negative 16, plus 12.5, plus 4. I should get 1/2, or 0.5. And 2.5. To check, you would have to plug back in each equation to make sure it makes sense. If I plug back in the first equation, I should get 8 plus 7.5 minus 2.5. Yeah, that does equal 13. You can check the other one. I'm pretty sure we did it right. I'm pretty sure we got it. If I go back to Desmos, I think I could see the answer in Desmos. Now I think I know what I need to do. I think I have to actually change the, let me clear my drawings for a moment. I think what I need to do is change the scale here. And go from negative 10 to 10. Yeah. It's awfully hard to tell where they touch.
Doesn't say.
I don't know if it does. Yeah, I tried. I don't know. Yeah, it looks like this is in beta version anyway. But so anyway, that's that. So those are the answers. Yeah, kind of a painful process. So you are going to do it because I do want you guys to go through the process, but there is a better way. The better way is actually in the graphing calculator. I'll show you really quickly, and then we'll be done for today. Some of you guys might even have an app that can do it. Let me think here. Math department, Wabbit EMU, browse. Okay. Yeah, you're gonna do something called a matrix. It's really, really confusing at first, but if I'm recording this, so you guys can watch recording later. So you hit alpha zoom, and you select something called a 3x3 matrix. And what you do is you put in all the coefficients of your equations, but they have to be all like written like this in standard form. So I put 1, 3, and negative 5. 1, 3, -5. Then I put 4, 3, -5, 4. And again, this is being recorded, so you can check it out at home. And then 2, -5, and 1. Okay. This is the part that's a little strange. Yeah, Ben, go ahead. Alpha zoom. Alpha zoom. Then what you do is you raise this to a -1 power. So you do that. And then you hit alpha zoom again. You make this a 3x1 matrix. And then you type in, and again, I'm not going over the theory, so you don't know why this works, because I feel like I should tell you why it works instead of just telling you just do this. There you go. That literally took me like less than a minute.
Can you put those instructions? Would we be able to allowed to do
The
that?
video. Yeah, you are going to do this on a test.
I can put it into.
But what you have to do is you have to show me how things get rearranged. We're going to cross that bridge later. Don't worry. But that's a way you can do this more efficiently. I'll recap one more time. So alpha zoom. Oh, I thought I got. Did I get the first part too?
Yeah. What's the first part? I'll look at that.
Yeah. So you make a 3x3 matrix. And you type in all the coefficients. I know you guys can type stuff in. I'm not worried about that. You raise it to -1 power, so you hit the X -1 button. You go back to alpha zoom. Now you do a 3x1 matrix. And you put these numbers here, 13, 37, and 4. What this does, it'll isolate X, Y, and Z all at once. So this is called a matrix. This actually really opens up a lot of possibilities of what you can do with math. For those who are interested in like in studying economics, data science, you do a lot of this stuff. Amazon, the one of all those crazy websites, they use matrices to keep organize all the information, and they do a lot of different transformations of those. It really helps you to work with a lot of information in a more concise and efficient manner. So we'll cross that bridge. We'll talk about the theory behind it, why it works the way it does. And with that, I think we're done.